Hello class, and welcome to today's algebra lesson, which is about descriptive modeling and accuracy. By the end of today's lesson, you will be able to use descriptive models to generate metrics, and you will be able to choose an appropriate level of accuracy based on the scenarios. First, a descriptive model is a way to mathematically represent real-world situations and the factors that cause them. So a descriptive model is trying to form a metric, which is a way to assign a number to a characteristic or attribute. So, for example, we have ERA, earned run average in baseball. It takes the different quantitative measures of a pitcher's game, so things that you can get from the statistics, and puts them into one single measurement, one metric, to compare how well pitchers are doing. Another example would be debt to income ratio. This is the way that a bank can compare different lenders to see which people qualify for loans. They take their amount of debt, what's causing all of that, and they compare to their income to see how much money they have flowing in and out. Accuracy is how close a measurement is to the true value. So this is how close can we get to what actually we want to have. Accuracy we are looking at is going to tell us when we are rounding, when we are not, and what is our best model for doing that. So our first descriptive model we're going to look at is something called the academic index. It's something that universities use to assess high school student-athlete recruits. The formula is shown below. So this reads as 2 times the quantity of the reading plus the writing score divided by 2. So finding the average of the language arts scores, adding in math, and then dividing by 20, and adding on the GPA value. GPA values can be calculated from the table. At a particular university, they require an academic index score of 186 or higher. If Kenzie has a 3.1 GPA, a score of 610 on reading, 640 on writing, and 700 in math on the SAT, does she meet the university's requirement for student athletes? So we're going to start by filling in our formula. I'm going to have 2 times the quantity of her reading score, which is 610, plus her writing score, which is 640. That's going to be in parentheses, divided by 2. Plus the math score, which is 700, and that whole thing gets divided by 20, closing that bracket, and then adding on her GPA value. We come down to 3.1, and her GPA value then is calculated in at 68. Now we want to go ahead and solve. So first we're going to do PEMDAS. So 640 plus 610 is going to give us 1,250. That's still going to be divided by 2 plus 700 over 20 plus the 68. Then I'm going to go ahead and do the fraction part. So I've got 1,250 divided by 2, which is going to give me an answer of 625 plus 700 dividing by 20 over 68. As I continue, I do my 625 plus 700, which is going to give me 1,325 being divided by 20 plus 68. If I do 1,325 divided by 20, I'm going to get 66.25. Next is my multiplication by 2, which is going to give me 132.5 plus 68 gives us Kenzie's academic index score of 200.5. If the university requires 168 or higher, yes, Kenzie would qualify as a student athlete that could compete for them. Another example we're going to have here, Rochelle wants to determine the best state park for hiking and fishing. She's come up with this model that says a park score is 20%, so 0.2, based on the online rating, the rating that it has out of the 5 possible stars. 40% based on the miles of trails, taking the maximum trails and seeing how much of that any particular park has, plus 40% emphasis on the fishing weight, taking an average of 10 pounds, and dividing out what they have. So I'm going to walk through the first one with you. We're going to look at Gooseberry Falls. So plugging into our formula, we're going to have 100 times 0.2, 4.8 over 5, plus 0.4 times 20 divided by 25, plus 0.4 times 9.8 divided by 10. The next step you would do is do all of that division. So we divide out each value and multiply it. So I've got 100 times my first value, plus my second value, plus my third value. I finished solving inside the bars, which would give me 0.904, and multiply by 100 gives me that first score is 90.04. I want you to go ahead and calculate first the Lake Maria score. As you calculate that score, plug in the values, solve step by step, you're going to get 72.4. Go ahead and calculate the Maplewood score now. Again, plugging in your values and solving, you're going to end up with a score of 88.8. And finally, calculate the Camden score. Plugging in your values and solving, you end up with 82.88. So, which park should she select as the one that she is going to go hiking and fishing at? The correct answer is Gooseberry Falls because it has the highest park score. Now, I said in the last one that Rochelle put an emphasis of 20% on online rating, 40% on trails, and 40% on fishing weight. If Jose values fishing more than he values hiking, how could he change the equation to match his preference? In order to modify the equation, he could increase that percent on fishing, so change that up to 0.5 or 0.55, and decrease the percent on hiking, make it 0.3, 0.25. So he can fluctuate those percentages, and that's what we can do with a lot of these descriptive models, is as they make a formula to describe a characteristic, it can be modified to suit whatever needs you have. Looking at comparing models now. So Elan is applying for a home loan at National Bank. They use his debt to income ratio, and it must be 0.36 or lower to qualify. At New Savings Bank, they use the mortgage to income ratio, and it must be 0.2 or lower. Which bank should he use? So first, I want you to go ahead and calculate for National Bank using his debt to income ratio. And we would take our debt, which is $1,165, and divide by our monthly income. And when I do that, I get a long decimal, but I want to round that off at 0.32. Now we're looking at the other bank, New Savings Bank, and they use the mortgage to income value. So I'm going to do 1,068 divided by the income of 3,650. Again, you get a long value in your calculator, and I'm going to round to 0.29. We round to 2 decimal places because that's what they gave us in the problem. So based on the accuracy, they're rounding to 2 decimal places, so we should round to 2 places. So based on what we have here, which bank should he choose? The correct answer is National Bank because his 0.32 at National Bank is lower than their qualifying standards. Moving on to some more of that accuracy and determining rounding. Damian and 2 friends are taking a road trip. They will drive equal parts of the trip. the GPS, which is going to measure to the nearest whole mile, shows that the trip is 172 miles. First question, what is the exact distance that each person is going to drive? So when we do this, we're going to take my distance of 172 and divide by the 3 people. Once I do that, that's going to give me 57.3 repeating miles. So that would be my exact value. Now it's asking, what is the appropriate answer based on the limitations of the situation? In the problem, it specifies that the GPS is only rounding to whole miles. So the appropriate answer here would be to round to 57. So the appropriate answer here would be to round to 57 miles per person. Go ahead and try this one on your own, first determining the exact number that she can build. So the exact number is 38.375 cars. Based on this situation, what should the answer actually be for this problem? The actual answer should be 38 cars. You cannot build that full 39th car, so you would round down to 38 cars. Another thing we want to look at when determining accuracy is, does it actually make sense for us to count to an exact number? So for example, the U.S. Census Bureau website shows a counter that is constantly tracking the population. This is true. You can totally go online and look at this tool anytime that you want. On a certain day, the website shows the picture below. So saying that our population is 332,737,797 people. Is this an accurate reporting tool? So as cool as this feature is on the website, it's actually not very accurate. The reason that we have to consider is how many factors they are constantly calculating. So they're saying that there's a birth about every 8 seconds and a death about every 12 seconds. But we're constantly changing the amount of population, and there is no way to be certain that this is actually the number of people that we have in the United States. So how do we deal with this? A better way in this case is to give a less precise answer. So we want to be close. So as we're looking at this, I could round to the millions. That's going to be a range that we can deal with. So I'm going to say that there's about 332, and then I can say, so that we know we're rounding, I'm going to say 0.7, because that tells us this is not exactly accurate. So I'm going to say there's 332.7 million people. That takes off these last place values and makes it so that we are rounding to an answer that's probably more appropriate than trying to count down to the exact person that we have. Go ahead and try this one on your own. Given this scenario, the best description here is B. The magazine is probably accurate because the number is not very specific. 37 trillion is 37 with 12 zeros after it. Those 12 zeros, those 12 place values could be filled in with any amounts of numbers. So it's easy to round and fluctuate on this one. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.